Hi, welcome, fellow job havers. Let's say, for the sake of the argument, you decided to touch some grass. And suppose on this grass touching, you spot two government surveillance drones that are the same species, but they're not identical. Why is that? According to the fancy science of genetics, there are three flavors for phenotype distribution: incomplete, which commonly produces the blended hues found in snapdragons and other flowers; codominant, most notable for the AB blood type and Rowan cattle, which I've attempted to capture in 4K; and lastly, the only type that sane life forms like us use, Mendelian. Mendelian uses a dominant and recessive gene system, which keeps the math clean, something you can't say about the average comp sci major. JK, chat, please don't hurt me. The best way to imagine it is capital A, or whatever letter you're using, is dominant, like an alpha signal male, and lowercase a symbolizes a recessive gene, which is like a soft, kawaii, performative catboy. If you lock them both in a Bay Area LinkedIn party full of ABGs, the alpha will attempt to monopolize the convo. The quiet catboy will only meow for his kitten if there are no alphas to ratio him. One of the most powerful tools in introductory genetics is the Punnet square. If we start out assuming both parents are dominant, we will see 100% mini Chads. Likewise, if we were to assume both parents are recessive, all the children will be mini catboys. This is about as interesting as trying to hold a conversation with a toaster. ChatGPT 4.0. But if we were to actually build our deck with a mixture of dominant and recessive traits, as shown here, we'll have differing percentages depending on if we have more recessive or more dominant traits. It's a genetic gotcha roll. It's like gambling, except instead of losing your life savings, your child ends up giving Minecraft villager look in awe. Now for our practice problem. Labubus have been found to contain the Mendelian matcha allele, capital M and lowercase m. If one Labubu has the genotype lowercase m, and another contains the genotype uppercase M, lowercase m, what is the likelihood of a child with a dominant phenotype? And time's up. There is a 50% probability, a 2 out of 4, or 1/2 probability of the child having the dominant phenotype. Thank you so much, guys, for watching. I didn't cover everything in this video because I know there's linked genes, chromosome mapping. Maybe in a future video I might talk about it. This is just an introductory primer into genetics. I hope you enjoyed this style of video. If you have any comments or suggestions or corrections, feel free to leave them in the comments, and I hope to see you guys later. Bye! Cheers!